G'day, it's Prezzo. Thanks for stopping by. Now I'm starting on a new project today. It's a complex build and there are lots of elements in this build that I've never tried before. So there's every chance I'm going to crash and burn on this one for your entertainment. But I've got it sitting on the bench here, so let's have a closer look and then we'll talk about some of the issues. Now this is the subject of today's video. Now this is called a Cleveland Racer. Now it's a vintage aluminium toy car and it dates back to about the 1920s or 1930s. Now the reason I know that is that it belonged to a friend of my father's. Now the story is my father was born in Wellington in New Zealand, but before he reached school age his parents moved to Auckland, and on the first day of school my father was being led along the street by his mother, and evidently my father was not happy about going to school and he was crying and grizzling. And he didn't actually stop crying until he spotted a boy about his own age who was dragging this exact same car along the street, towing it by a piece of string. Now they got talking and became friends, and in fact they became lifelong friends. And his friend's name was Jim Lever, and before he passed away he sent this car back here to Australia to give to my son, who coincidentally is also called James. And also coincidentally he now lives in New Zealand, in Wellington, not far from where my father was born actually. And I wanted to return this car to him because it's been in our house ever since it came back to Australia. And before I do that I want to make two replicas of this car. Now it's going to be quite a challenge to cast this because if you have a look underneath there, it's hollow and the wall thickness is only about probably 1/8 of an inch, maybe 3 millimeters, and that is going to create quite a problem for casting in sand mould, because with wall thicknesses that thin the metal tends to freeze very quickly before it can completely fill the mould. Now also creating this hollow space underneath here is going to be a challenge. So that's the first thing. The second thing is that these wheels are no longer available. These were sourced in New Zealand about I think about 20 years ago. The company that made them no longer makes this particular wheel, and there are originals in the USA, but they're very expensive. With shipping and exchange rates they work out about $100 a wheel, and I need 10 of them because this car has 5 and I would need 5 for the other car. However, I can cast the wheel centres in aluminium. These are pressed steel, but I can make them in aluminium. And I'm going to have a go at casting the tyres in urethane rubber in a 2-part mould. I've never tried that before. That's going to be quite a challenge. And the other thing that was a challenge was actually creating the patterns for the body of the car. So this is one of the patterns here. Now this is 3D printed in PETG plastic, and you're probably saying, well, how did you create the 3D model? Did you just scan this with one of those 3D scanners? Well, no, I didn't, because those are very expensive still, about $1,000 to get a reasonable one. So I did it the old school way. I actually drew a 2D drawing of this car as both a side view and a top view, and then from the 2D drawings I was able to create the 3D model using Fusion 360. Now I'm going to show you how I did that because it's a useful technique. If you've ever had to model something like this which has got a complex form, it's worth knowing how to carry out the modelling process. So I'm going to show you how I did the 2D drawing first, and then we'll have a look at how Fusion 360 made this 3D model. I'm going to try and recreate how I made this paper drawing here because I don't really want to do it again. Now the top view is easy. You just simply place that over the paper, get a sharp pencil and trace the outline onto the paper. Now before I did that though, I drew a centre line, and then I had centre marks on the end of the car body, both at the front and the rear of the car, and I aligned those accurately over that centre line, and just get a sharp pencil and away you go, just trace that outline. So that's easy. Getting this side view here though is a bit more of a challenge. Now in order to do that I projected the length of the car down onto a second line, this line parallel to the centre line up here, and then I was able to align the bottom edge of the car with that station line there, and I've numbered this, and originally I was going to try to use a profile gauge to work out the cross section at each of those stations there, but at the end of the day I didn't do that. So the challenge now is how do you project those curved surfaces down onto the paper? Now, it's not as simple as you might think. You might say, well, just get a pencil and just do it that way. But then you've got to allow for the thickness of the pencil. And also you can't be absolutely sure you're holding that pencil dead square to the paper. So what I ended up using was a thing called a spiling gauge. Now, this is often used in shipbuilding for tracing off the shape of planks on a sort of clinker-built hull. And this one here has a sharpened edge, and it has a small piece of pencil which is aligned exactly with that sharpened edge there. So in practice, what you do is you make sure the car body is standing up vertically along this bottom face here, and then just simply run the spiling gauge along the outline of the car. So I'll set this up and I'll show you how I did it. In order to make the spiling gauge work, I needed to lift the car body off the surface of the drawing board. So I've just put that on a block of wood here, and I've just screwed it through the existing axle holes in the car body. And that gave me room to run this little section of the spiling gauge underneath the edge of the car. So I'll turn this around and I'll show you how that worked. In this view here, you can sort of see how the spiling gauge is going to engage on the surface of the car body, and it translates that point directly down through the pencil and onto the paper surface. So as long as you hold the car body nice and still and you keep that sharpened edge of the spiling gauge engaged on the surface of the car body, it will trace that shape onto the paper surface here. So it's just a matter of taking your time, going around nice and slowly. I was also able to get down into the cockpit and work around there, come up the other side, and then go down over the nose of the car. Alright, so you get the idea. Now after I finished with the spiling gauge, that line was a bit ragged and a bit rough, so I just went around with the pencil, tidied that up, and smoothed that into a nice uniform curve. Now this line here was the point where this flat surface on the side of the car, or reasonably flat surface on the side of the car, ran into the curve at the top. Now that was just done by measuring. I actually had some station lines on the side of the car here, and I was able to measure up that line, transfer the same measurement onto the drawing here, and plot those points, and then run that line as a single curve. I did the same at the front to work out where that line was. You can see it quite clearly here. There's a change in the profile. And then it was just a matter of measuring. I actually measured the distance up to find the axle centers. Then using a compass and a straight edge, I was able to draw in that shape for the boss at the front and the back. And this little line here was really straightforward. Just measure that and transfer that as a single straight line. Now that gave me a fairly accurate 2D pencil drawing. From there I traced that outline onto a piece of tracing film, and I was able to scan that traced image on my scanner, and that created a digital JPEG image that I was able to use in Fusion 360. Now the floor of the cockpit was just simply measured directly, and I just picked points where the profile changed direction and drew that in as a sort of a hidden detail line. And same at the top view here, I was able to sort of work it out just by measurement and draw in that shape there. So let's have a look now at how we put the scanned JPEG images into Fusion 360 and start modeling. So you see here I already have the side view in place on the vertical plane, and these images show up in the tree as canvases. So I'm navigating now to find the top view, and we'll open that, and that's going to get placed on the horizontal plane. And you do need to zoom in and make sure it's aligned correctly. So the images actually came out much smaller than their real life dimensions. So here I'm rotating that top view into the correct alignment and moving it across. And because of some slight discrepancy in my scan, I also need to adjust the angular position So it worked out about 0.1 of a degree, and that aligns it correctly with the center line of the plane. Right, next thing you need to do is to calibrate that image. So you put an endpoint at both ends of the scanned image, and then put in the actual dimensions. So in my case it was 290 millimeters. You can see now it's quite a lot larger, but I do need to go back and align that accurately. So I'll go back to the top view, and we're going to edit that image and just move it across slightly. So now you can see that we've got a top view and a side view, and that's going to form the basis for the next modeling process that we're going to use. So we're going to insert a mesh. So the mesh that I'll be using is basically a rectangular prism. Work out which plane you want that to appear on, and then you click and drag to get the length and the height. In this case, length and width and height. So there it is there. And what you want to do is position that so it covers the two scanned images that you've placed on the planes. And you'll notice that I've set width and height symmetry. It's really important when you go to shape this. You don't want to be sort of grabbing hold of points on either end or either side. And you can set the number of faces for the length. I just set it to 12. More faces gives you more control over the finished shape. Right, from this point onwards, we're going to start shaping that rectangular prism or that mesh. So it's going to mean pulling points and edges up or pushing them down. And with a bit of careful positioning of those points and corners and edges, you can start to get a fairly good approximation of the shape. Now you notice that it automatically creates the symmetry between top and bottom, and also between the left and the right hand side. So it's just a little acceleration in the modelling process. It does take quite a lot longer than what you're seeing here. Now you can add extra edges and points if you need them. And that's getting pretty close to our overall body shape that we need. Now once you're happy with it, of course, you can actually convert that into a body, and then you can start to do all of the other processes that you need. So in this case I split it in half, and then instead of forming the cockpit as part of the mesh, I actually cut that out using a sketch. Now I'm adding in the bosses for the axles. And the most important part is adding the shell. And this is the part where it often fails. So lots of fillets. Alright, now you can see the shell underneath. And that's pretty much it. That was 3D printed, and that forms the outside of the pattern. This is a sort of a draft print of the original model that I made. And when I printed it, including the hollow underneath there, and sat it side by side with the original car, it just didn't look right. So it flared out too much where the radiator would be, and although when you held them against each other, they were very, very close, it just didn't look right at the front end here. So I went back and tweaked the model and just moved some of the points and the edges in a bit and down a bit, and this was the one that I printed last. So ignore the two colours there, I just ran out of filament. And this one is the actual pattern. So it doesn't have the hollow space underneath. Now that's going to be formed by a core, and I'm working on the core box now. And this one is much closer to the original. It's still not exactly the same. It sort of comes up a little bit too high at these corners here. It should be rounded off more at those two corners there. And when you hold these back to back like that, you might say, well, hang on, this one's too long. But this was printed at 102%, and that allows for some shrinkage in the casting. So it should come out a little bit shorter than that when it's finished. But overall, I'm very happy with the appearance of this one here. And nobody's ever going to see these side by side anyway. So what I'm going to do now is going to get all this sanded and filled and painted, and I'm going to work on the core box, and I'll show you that next. Well, there's one half of the core box finished and sanded smooth now with the fillet in place. And if you're wondering why I didn't just model that fillet in Fusion 360, trust me, I tried. And fillets are one of those things that will often fail for no apparent reason, and that's what was happening there. So I figured I'd just use the body fillet to do that, but it is very difficult to get in there and sand all of that smooth. But what I'll do now is give this a coat of the spray putty. Now this is the brand that I normally use, and I went down to the auto accessory shop to get another can, and of course the shelf was empty and ended up getting this brand here. Not as happy with this one, but it'll do. So I get this coated now and sanded smooth, and then we'll think about getting one of the cores made. Alright, I'll let that one dry. This is the one that I did earlier today, and this needs good sand now, but this stuff seems to take a long time to dry, so I'll probably leave this till tomorrow and start sanding that smooth. Well, after a lot of sanding, I've got my core box to look like that. This is going to get a coat of a red acrylic automotive lacquer on the inside there, and that just allows the epoxy and sand mixture to release easily. And when I 3D printed this core box, I accidentally used some ABS filament. I ran out of PETG about there, put the ABS in, and that's what happened. And that's why I never use ABS anymore. But this will be good enough to get, say, 4 cores out of it. So I'm going to screw this part on top of the core box, and that will form the core print. So when I've set the epoxy resin and sand mixture, which is what I use for making cores, I can remove this section. It'll be screwed on, and it's got draft angle on the inside, so it'll come off very easily. And then I can split the core box in half and remove the core that way. So it's just held together with dowels. So I'll go ahead and paint this now, and then I think what we'll do is we'll try to make the cores. And this whole project is contingent on getting a decent casting. And if I can't get that, there's no point in trying to make the wheels. So yeah, we'll make a couple of cores. I'll actually make 4 for 2 cars, because I anticipate that there's going to be a few failures along the way. It's come out pretty smooth. There are still some visible layer lines, but given that this is the core, I don't think it's going to be a problem. You can sand the core smooth when it comes out of the core box. Just having a really good look at this original Cleveland racer, and there's still evidence that it's been cast in a sand mould. So you can see it's sort of a sand texture inside this little corner here, and there's other places where it's really obvious. So looks like whoever made this didn't go to a lot of trouble to clean it up. This is actually damage. When I looked at that, you can see file marks there, and it's only on one edge. So I'd say this got broken at some point and somebody's just filed that out to make it look neat. And there's a lot of wear on the bosses where the axles and wheels go through. And looking at these lines here, I'm not sure that they were cast in. I think they've been cut with some sort of abrasive wheel. Now I'm not going to try and cast that detail into mine. I'm going to add these lines afterwards. I'll use a Dremel and a cut-off wheel or something like that to form those grooves, and I'll file them smooth. So yeah, interesting. And you see the text on the inside there, and it says patent pending. I actually tried to find the original patent using Google Patents and came up empty, so not sure if they ever went through. I understand patent pending means that it's not fully patented, but I could be wrong there. Anyway, that's the original. Well, there's a finished core box. What I'll do now is to make up one of the cores, and I'll do this fairly briefly. I've covered this before in previous videos, so I'll put a link in the description to one that shows the process in more detail. But what we're going to do to start with is to fill this core box with clean, dry, white sand. And then when it's completely full to the top, we're going to tip that out and weigh the amount of sand that we have. Then I'll dismantle the core box, and I'm going to coat the inside of the core box with a furniture wax. It's like a liquid furniture wax. Just make sure you get a good liberal coating on all of the surfaces that make contact with the sand and resin. Now we can calculate how much resin we need to mix with the sand. Now I'm going to shoot for around about 8%, but I'll probably use less than that, usually between 5 and 6%. And the idea is you just keep adding the resin and mixing it until it resembles greensand. So you should be able to squeeze together with your hands, and it should sort of hold its shape, but you shouldn't see a lot of liquid epoxy resin in the sand. At that point we can start filling the core box, and we're going to tamp that down to make sure that we don't leave any pockets or voids. We just want to make sure it's completely full, but you don't ram it down like you would if you were making a mould for a casting. Now at that point we need to leave it overnight, so we'll check it out in the morning and we'll see how well it's cured and whether we can actually get it out of the core box. That's going to be the interesting part. That resin is fully cured now, so I left these overnight. So I'll get this apart. These holes that I put in the top of the core are just vent holes. They'll allow gases to come out of the core when the liquid metal goes around to form the casting. All right. Okay, that was a bit more of a struggle to get out of the core box than I thought it was going to be. And in the process, I think I bent it. So when I took it out, I noticed that this bottom section here wasn't completely flat, but it's gone flat now. So I'll put this in the oven and warm it up. The other thing is it's been very cold here overnight, and I'm not sure that epoxy resin is fully cured, but warming it in the oven will do that. But it's got all of the detail is there. This is where I ran the bent wire through the side of the core, but I can patch that up, and really happy with the surface finish on it. It's really smooth, and I can clean up that little flash line with some sandpaper there and in the middle here. So that part of it's good. I will make 3 more of these because these are definitely a single-use item, and if I mess up the casting, you've got to have a brand new core to use for the next casting. So yeah, pretty happy, but yeah, it was quite difficult to get out of the core box. Just to finish up today's video, I thought I'd do a quick experiment to see whether it was feasible to get this pattern out of a sand mould. Now, what I was worried about was that this big lump of sand down in here, which forms a cockpit of the car, might shear off and come out with the pattern, but it didn't. The surface finish on the cavity is excellent, so I'm really happy with that. And the core that I made will be lowered into that cavity, leaving a wall thickness of only 4 millimeters. And that's going to be the issue. Can we fill up that very thin void with liquid metal and have it come up the sides without it freezing anywhere? But I have upgraded my pyrometer, which is going to allow me to check the temperature of the molten metal more accurately. And I'm going to pour it fairly hot, around about 730 degrees centigrade, and hopefully we can get the metal in there without it being a problem. Now what I'm thinking is I'll have a runner on this side here and a couple of gates attaching to that sort of a belt rail around the side of the car, and then on the other side, the same thing, we'll have a couple of gates and a big riser over this side here. That's my compressor. I fitted one of those automatic purge valves on it, and it goes off every 20 minutes and it scares the living daylights out of me. Now, what was I saying? Yeah, so that's going to be next time. We'll have a go at actually casting a couple of these car bodies, and we'll see whether that's going to work. If I can pull it off, it'll be a miracle. Now, I want to take you next door and I'll show you some surfaces that I treated using Dan Gelbart's alkaline water wash method, and I'll show you how that's held up. It's been about 2 weeks since the previous video on rust, so I thought you'd like to see a follow-up on how that went. This is the bandsaw table that I did in the last video with that alkaline water mix, and I've got to say it's a bit of a mixed bag. This side of the table here is perfect. There's absolutely no rust on that at all. Along this back edge and this corner here, I can feel some little pimples of rust starting to appear on that edge there. Now, a viewer did point out that if I add some detergent to that alkaline water mix, it will act like a wetting agent and will cover the surface more completely. Now, it could be that when I sprayed it down, there were some little voids and holes where there was none of that alkaline water mixture on the surface. So I've since added the detergent to the mix, and I did the cast iron table of my table saw, so let's have a look at that. So this is the surface of my table saw. It's cast iron. I cleaned all of this down with some fine sandpaper and a green Scotch-Brite. I wetted that down with the alkaline water and detergent mix, and I noticed that it flowed out really well and completely covered the surface here. But weirdly, there's some little orange marks down in this rebate. Now maybe I didn't squirt it down there enough, and then over on this side here, there was a strange mark appeared about the size of your thumbnail, and it had quite an orange rusty patch there. But it was just this one isolated patch, which I can't account for either. So overall, I think this has turned out okay. I've done nothing else to this surface since it dried, but I got the feeling that adding wax over the top of this now would be a good idea. Now I'll show you the other surface that I did, and it's not so good. This is the table on my homemade disc sander, and this is just 1/4 inch thick hot rolled steel plate. And this was really rusty before I treated this one, and I got a random orbit sander and went over that and cut it back with a fairly coarse disc, and then I treated it with the alkaline water solution. And weirdly, this one has quite a significant rust patch just there. There's another one there, another one there. Now again, I can't account for that. I don't know why. I get the feeling that this treatment, in conjunction with a coat of wax, would be a better solution. But it's early days yet. I think there's more to be learned about this process, and I will follow up in future videos and let you know what I found out. But I think it has a lot of merit, and yeah, maybe somebody else who's sort of been doing this for a long time will let us know how it went for them. But I'm going to finish up here now. I've just got a couple of wildlife shots to show you, and then I'll see you next time when we try the castings on the Cleveland car. Okay, Prezzo signing out for now. Thanks for watching. Cheers.